So I'm going to cover section 5.7, completing the square from the bonus homework. So we're going to talk about completing the square. Two things we need to remember is that when we integrate arctangent, the form we need for arctangent is going to be 1 over 1 plus something squared dx. As long as we can get it in that form, then we're good. I'm going to start on example 4 and talk about why or how we get it into that form. So example 4 has this form. This is on page 382. 1 over x squared minus 4x plus 7. What I'm going to do is complete the square, and how we do that is we isolate the x's. So let's just view the problem, just the integrand. So we're going to go x squared minus 4x plus blank plus 7. Now here's the problem. We're going to add something here to complete the square, so we have to subtract it away to cancel it out. Otherwise, we're changing the problem. How do you figure out what goes in here? Review from Algebra 2. You take the middle number, -4, divided by 2. Square it, so -2 squared is 4. That means we're going to subtract 4 from this side. Okay. The beauty of completing the square, remember, is now that I can rewrite this problem as the parentheses part can be rewritten as x minus 2 squared, and then I have a 7 minus 4, which is plus 3. If you're not sure where the x minus 2 comes from, I just factored this. So now I can go ahead and integrate this. A couple things I need to be able to integrate an arctangent. Let me switch the order. First thing is I need a 1 in this spot. In order to create a 1 in that spot, what I'm going to do is just divide everything by 3. So I'm going to divide that by 3, divide that by 3, divide that by 3, and that should mathematically be fair. Okay, then I can pull out that 1/3, and here's what I have. Integral 1 over, now I have the 1, and I need to rewrite it as something squared dx. Okay, so what I need to work on is, can I rewrite this as something squared dx? Well, it's going to be x minus 2. That'll get me the top, but the bottom's a little bit trickier. You have to actually rewrite it as rad 3. Okay, so there is the form. I have 1 plus something squared. So I should be able to integrate it using arctangent. Don't forget I have to do a u sub. U is going to be x minus 2 over rad 3, or another way you can view that is 1 over rad 3x minus 2 over rad 3. Okay, just to simplify it. Take the derivative, so I can do my u sub. Derivative is just 1 over rad 3. And so if I solve for dx, my dx will then be rad 3 du. Okay, so I think you can see from here that another rad 3 is going to pop out. So I'm going to have a rad 3, and then I'm going to have the rest of my integral over 3 from this integral 1 over 1 plus. That whole thing is now going to be u squared, and then I'm going to have a du. So this has the correct form for arctangent. So it looks like that integral is just going to be rad 3 over 3 arctan of u. Our u is this, x minus 2 all over rad 3 plus c. The book might have it slightly different, but that's the same idea. Okay? We're going to next look at example 5. In example 5, we're asked to integrate this. What this looks like is that we're going to probably have to get it in the arcsine form, which looks like 1 over square root of 1 minus something squared dx. Okay? As long as we can get it in that form, then we're good to go. What I really just need to do is I just need to focus on the completing the square for this part. Okay, so how do I complete the square? Well, first thing I want to do is maybe rewrite it so the x squared is on top. Okay, so negative x squared plus 3x. Keep in mind, you can't have a number in front of the x, so I actually need to pull out that negative. So it's going to go negative x squared minus 3x, and then I'm going to complete the square by adding a plus blank, and I'm going to cancel it out with a minus blank. Again, to figure out what goes in the blank, take the middle number, -3, divide it by 2, and square it. So it looks like going in here is going to be 9/4. Well, normally you would put a 9/4 here. However, you have to watch out because of that negative. You have to distribute it through. So it's going to be actually a negative 9/4. So when all is said and done, that is actually rewritten as x minus, if you're not sure, it's usually what's in the parentheses, 3/2 squared, and then I have a plus 9/4. Okay, so I'm going to stick that in there and work out the arc sign. So the integral is going to look like integral 1 over radical. I'm going to switch the order. 9/4 plus, or sorry, minus, because of that negative. So 9/4 minus x minus 3/2 squared. Okay, there's a lot of things you have to do, because remember, you need a 1 in this spot. Okay, and it has to be something squared, but I'll leave that to you. Okay, this next part is going to be section 5.5, and the question we want to answer, I'm working on page 362, if you're wondering, example 3. So here is example 3. There's 3 parts, I'm only going to do 2. So the first is, how do you differentiate something that doesn't have a base of e? Because I know that if I differentiate e to the x, it's just e to the x, but that's not the case here. So how do I do that? There are some formulas in the book, but the idea behind this is that I can actually rewrite this a certain way. So if instead I see 2 to the x as e to the ln 2 to the x. Now this might seem like a strange way of rewriting it, but I just want to bring the e into play. Okay, so e to the ln of 2 to the x. Well, then what does that look like? Okay, notice I can bring the to the x down. So I can rewrite this as e to the x ln of 2. Then all of a sudden you have the e to the x going there. Okay, so let me split this up. I take that back. I'm not going to split up because ln of 2 is just a constant. So now when I find y prime, the derivative of e is just e, so I don't change anything. Times the chain rule. Okay, now the chain rule is asking for the derivative of this part. But ln of 2 is just a number, so it's x times a number, so it's going to be times ln of 2. I'm going to do the move where I'm going to actually bring this back up to the front. So what the problem now looks like, just to simplify it, is I have e to the ln of 2 to the x times ln of 2. Well, we know e and ln cancel, so you just get 2 to the x times ln of 2. So that's how you find the derivative if you don't have e as the base. So if we look at part b, y is equal to, in this case, 2 to the 3x. I'm going to apply the same idea, kind of rewrite it as e to the ln of 2 to the 3x. Okay, bring down the 3x, so I'm going to get e to the 3x ln of 2. Okay, if that kind of weirds you out, let me just combine 3 ln of 2, then the x. Okay, so the derivative, y prime, again, the derivative of e is just e, 3 ln of 2, x, times the chain rule of the top. 3 ln of 2 is just a number, so I'm going to have 3 ln of 2. Okay, again, I'm going to make the move to bring this up. And also bring the x up, actually, so it might be easier to say I'm going from here and I'm bringing that back up as an exponent. So what I'll have is I will have e to the ln of 2 to the 3x times 3 ln of 2, and you can simplify from there. The last part, I'm going to go over how do we integrate. So this is off example 4 on page 363 of the same section. So how do you integrate 2 to the x? How do you integrate this when the base is not e? Again, I want to try to see if I can involve e by rewriting this as e to the ln of 2 to the x dx. Okay, same thing I did with differentiating. I'm going to rewrite this as e to the x ln of 2 dx. So now I can integrate easily, but I have to do a u sub. So I'm actually going to let u be x ln of 2. ln of 2 is just a number. So du over dx is ln of 2. Okay, so notice that's going to be the constant that's going to pop out. And so I can actually do a quick rewrite of the integral as 1 over ln of 2, then the integral of e to the u du. Okay, integral of e to the u is just going to be e to the u plus c. So that's where we get 1 ln of 2, 1 over ln of 2, e to the, I can rewrite it x ln of 2 plus c. Okay, so 1 over ln of 2, e to the, I'm going to bring the x back up to the top, plus c, so then this will cancel. So it looks like 1 over ln of 2, 2 to the x, plus c. Okay, that's how you integrate. On the bonus homework, I should see all these steps.